So this is going to be a tutorial on how to get started with Python. This is kind of aimed for geoscientists or future one of people interested in geodata science, or just people interested in using Python in their workflows, particularly in geology. One thing I would advise is do enough tutorials that you can get started, but as soon as you get working on your own data set, that is where you really start to improve your skills. So my name is Drew. I'm a geologist since 2004, graduated in 2004, and then I did my computer science degree. And ever since then, I've been trying to push more computer science, geoscience, that interdisciplinary field. And programming is only one part of that, but a big part for sure. So my team in 2022 at the University of Saskatchewan also won the 2022 Frank Arnott, and Python was a big part of my contribution to that team. All right, so without too much ado, let's move on to the actual tutorial. All right, from here, you can see a website here, or the browser, I should say. We're gonna use two paths here. The first path we're gonna use is Colab. Colab's intended to get you really quickly programming. You don't need to install anything on your own computer, but it is cloud-based. But it is a really good way to start learning. The other one is by installing Anaconda on your own computer. We'll spend most of our time on Colab because it just gets you going quickly. And I'll show Anaconda at the end because if you do really want to start leveraging large data sets, being able to work offline, then you do need to Anaconda. But if you're just learning programming, Colab's a great way to start. So what is Python? Maybe I should actually describe Python a little bit. Python is what's considered a high-level programming language. In a large sense, when we write these programs, we need to write in a way that the computer understands what to do. Low-level programming languages are very complex. They're hard for a human to read. They're easy for a computer to read. The high-level languages build more for humans. So Python should be easier to read. You should be able to understand what the program is doing. And that is the intent of these high level programming languages. So, starting with Colab, you're going to want to go to a website called colab.research.google.com. So I'm already logged on to my account, but you're going to need to log on to your own. You'll see this this interface here. There's lots of things you can go into deep detail of what this can do. But what we're going to do is we're going to start a new notebook. So a new notebook in Drive. Going to spin up another computer somewhere. Computer that's off in the cloud that's now running for your notebook. This is something called a Jupyter notebook. This allows you to generate code and text together. Allows you to execute code in single snippets, which is a really, really good way to learn, a good way to develop workflows. You don't have to run entire scripts of programs, entire scripts to see if everything's working. You can just start little bit by little bit. So we've started a notebook. We're going to rename this notebook to, oh, what's a good name? My first notebook. All right. So we've got that. Now, right in here, see my cursor there, we can start coding immediately. Let's do the typical hello world. We're going to first type in something called print. Print is a command that allows you to essentially it tells the computer to print something back in the display. So hello from a geologist. Very simple. Now we've got this. If you hit Shift Enter, it'll run this code. taking an extraordinarily long time for something so simple, but this is one of the issues with running from a different computer. So it displays that hello from a geologist. Now, if you did something like this and you did not include this syntax exactly, you now have print with no double quotation marks, you're going to get an error. One of the reasons I wanted to really show this is that after 10 years of programming, I still get errors all the time. Errors are just, they shouldn't be something to be scared of. They happen all the time, and the key thing for programming is once you start to learn to understand what these errors mean, then it becomes a lot easier. So this is a simple syntax error, unterminated string literal. So it tells you what's going on, tells you the line it's happening on, very first line. And even this is all AI generated actually, so you can actually go to explain the error now. Now, I'm not going to do that for you. We'll just fix the error and move on. Fixed error. Run it again. We're fixed. I'm going to show you my repo later, and I've built a kind of a cheat sheet for you to look at some of the errors and what they mean, but I'll show you that shortly. All right, so next thing I'm going to show are variables. A variable is a very important concept in coding. It allows you to give a name to a value so you can use it later. Very common one I'd use is whole ID. So H01. And then maybe we have a grade. And that could be, actually we're going to use number. So in these two cases, a type is in Python, very important. So this is treated as a number, this is treated as a string. I'm not going to go into the details of how what you can do with different types. That'll be for later videos. But the key thing for this is you could write an entire script that does something with a very specific drill hole. And maybe in the future you want to do the same thing, but with a different drill hole. If you organize your code so that all your commands just use whole ID instead of the actual hard-coded number that you would use, you can now just change it here. So if I ran this, it's going to print the whole ID. If I change it to 3, it's going to print that ID. So you can see, you can kind of conceptualize how this would be very useful, and you do want to try to do this as much as possible. Also makes your code easier to read, because you might say print 4.7, but if you're looking at long lists or long lines of code, you might not know why it's doing something with the number 4.7. If you instead said grade, then now you know what that particular part of the code is trying to do. All right, so a lot of tutorials online might quickly go into how to build games and programs and stuff like that. Data science is very different, and I really want to push quickly to get into working with data. The sooner you get working with data, the better it is, because you need to be doing Python for your purposes. So I have on my GitHub a repo. I'll put a link into this associated with this video. You go to your Geodata Science Python intro, and we go to video 1. There's a CSV called here, assays.csv. It's all fake data, something I made that you can download. You go over to this number here, or this icon here, you can download the raw file. Also, just for your information, the errors cheat sheet is located here as well. So once you download the file, we go back to our notebook, come over here to files, and you can go to upload. Now I'm going to upload the assay data. I've already downloaded it. This is the key thing here too, and this is one of the faults of using Colab, is you're putting your files on the cloud. If you're using company files, that's a consideration as well. If this is not data you want up in the cloud for security reasons. You don't want to throw that up there. But also, when your computer shuts down or when you close down this notebook, all the files are removed from your workflow. So if you need to reload them, you can, but that's just an important thing to consider. So we're going to go very quickly now into, we don't use AI. AI is a very useful tool for coding, but we're not using that right now. So we're going to start importing this data. So pandas is a very, very useful data science library. One thing about Python is the use of libraries. Libraries allow you to access code that other people have written that can make your life more simple, make it easier. And one of those very common things is using something called a data frame. And a data frame you can think of as like a sheet in an Excel file. It's a flat file with headers, rows, sometimes headers, I should say, but columns and rows, and you a lot of data science is manipulating all that data. So pandas, we're going to import that so we can use some very simple methods and functions that pandas has built, and the as PD just lets us simplify our code. It gives us sort of like a nickname for pandas. So we're going to create a data frame, DF, commonly used abbreviation for data frame, but you can name it anything you want. You could call it diamond drill hole data frame, whatever. Now, PD, that allows us our nickname. For pandas, it means, and we put this dot there, that means we're going to go into the pandas library and we're going to find a function and we're going to use it. And in this case, we're going to use read CSV. And then we're going to read in our assays CSV. So a key thing about programming is learning what all of these different functions are, finding new functions that you can use, building learning libraries. Really a big part of programming is learning all these libraries. You find a new library, has a whole bunch of interesting functions that do some interesting things. You incorporate that into your workflow, and that is a big part of programming. So we're going to do that, and for a notebook, you don't have to put print. If you just write like you could do print, but no, notebooks have some hidden codes in the background that make life a little bit easier and display things properly in a notebook. So you can just write the variable and it will print it out. So, oh, what did I do wrong there? Okay, very easy. I did not name the variable right. Great example of how I still get lots of errors. So now we can print and see our data, our CSV. Great, awesome. Now, say I want to add a new thing of code here because we might want to do something more interesting. There are other types of methods you can use on your data frames. These come in from pandas as well. So describe is a very often used one. Describe will give you a one-line sentence. Will give you a table on the statistics of your data set. So how many counts, how many rows across. This might include null data. It should include null data if null data is actually recorded as null data. The mean, standard deviation, min, your 25, 50, 75th quantile, and the max. So very, very simple stuff. You can see your max gold here is 6.2 grams per ton, and copper is 1.12%. What are some other ones? Info will give you info about the database. I can't recall off the yep, we're good. 20, so gives you your shape, what's called the shape of the data set, 21 rows, the columns, and what the columns data types are. So These are floats, and lithology is considered an object. In this case, it's a string, but it's considered an object. I'm not going to go into the details on that. But maybe we want to do something more interesting, like let's look at, put square brackets here. You can pull up specific columns. So let's look at gold, GPT, and I want to find the average. If I run that, I EDH, so I misspelled DH to DF. Very quick. So that's our average. So that's really, I can go into more. There's a ton you can do. Maybe you want your standard deviation. If you want, you know, there's a lot of different, you can get your single max. Just want that. Lots of different things. You can even do things, you can pull these into your own variables. So I want my max gold to equal the max there. And then now I've created this script for this code line that actually pulls that in, and I can start using that max and the rest of my code. All right. So I've kind of gone over a lot here. The most important thing, I think, for anything in any work here is to know how to save this. That's very simple. You go to save a copy in your drive. I won't click this, but when you save a copy in your drive, for Colab, all your data is being stored in Google Drive. You can download this as well. You can download it as a Python file, or what's called an IPYNB, which is a Jupyter notebook, and then you can load this into other programs. So that's another thing, is if you start using something like Anaconda, you can download all your files here and load them up that way as well. So you can do your main working here as you're learning and pull them into Anaconda later. So let's move to Anaconda. The Colab is really good and it's really good for ease and getting into it. Nothing to install. Anybody can do this. They just open up the website and start going. But if you're working with big files, anything over 1 gigabyte, if you're working offline, if you have sensitive company data that you don't want to upload to Google, and you want to get more into like more of a development setting, then you want to go to anaconda.com. Download. So that's gonna get you started here. You go through this. You might have to set up an account. I'm not going to go through. Yeah, you will have to set up an account. I'm not going to go through the whole process. I have it downloaded already. Download and install. And then you open up your Anaconda Navigator. So I'm not going to upload it at this time or update it at this time. I'm just going to open it up. So here is Anaconda, the interface for Anaconda Navigator. A big thing here is Jupyter Notebook. So you'd want to launch your Jupyter Notebook. What you're going to see after this, it's going to open up a browser, and it's going to open up the same looking interface that you've seen for Colab. So all these things, these are a lot of my other files and stuff like that. So you can open up a new notebook and start building there. That does allow you to do things more on your own. So we've opened up Colab, run your first code, loaded a data set, computed a very simple statistic. That's where I'm going to stop it at this video. The next video, I'm going to go more into, less into like the actual geoscience, more into what makes good coding. Because that is really where I can add a lot more to the community, I think, is my computer science degree has taught me how to code properly, I would say. What good good mentalities, principles I'll bring up, like the drive principle in programming. These will come in the next video. But if you want to try things in the future, you could try loading the CSV and computing the mean of the copper column, or try filtering out by just a specific drill hole, because I did drill hole. There was drill holes named 001, 2, and 3 in that data set. And by all means, definitely try to bring in your own data, because as soon as you start doing that, and as soon as you start bringing in your own data and trying to solve your own problems, you learn a lot. All right, that's it for this video. See you next time.